just wanted to record these. So. Sweet. All right. I had written up on to do number 14 because I thought it looked kind of confusing. Would anyone like to see that? I just had written it up as an example. You want to see it? Okay, perfect. There, number 14. Oops, right, I'm trying to get to the right page. 2B was the homework last night? Was that right? Number 14. So I have 7 plus, and then I have 1/5, and 1/5 is going to be with parentheses. Did I write that correctly? Okay, now I'm going to show you all the steps. And I will try to always show you guys and girls all the steps. I get it. Sometimes you can skip a step. I get it. But I'm showing you all the steps just so we can make sure that maybe you didn't see where a certain step had come from. So the first step is I'm going to distribute the 1/5 here and here. So 7's coming along for the ride. The plus is still there. 20 times 1 is 20. So I get 20x over 5. And then minus 1/5 times 10, that gives me 10 over 5. Okay, now the step that might have been skipped here is you might have already realized 1/5 of 20 is 4 and 1/5 of 10 is 2. You might have realized that and you could skip it, but in case you didn't see that step, I went this way, so I get 7 plus, that becomes 4x minus 2. Are there like terms right there? Yes. And remember, the like terms are like apples and apples. And again, we gave the example yesterday that if you had 14 apples on one desk and 10 apples on another desk, you're counting all the apples up so you can add and subtract them. If you had oranges on another desk, you can't add them together to get more apples. They're not the same thing. So like items are 7 and -2. So I have $7 in my pocket. Something costs $2. I have $5 change. The 4x comes along for the ride. Some math folks would prefer to have the variables first in alphabetical order, followed by the constants. So some people might prefer 4x plus 5. They're the same answer though, okay? And I'll accept either. And then the next problem we had, is that number 15? Am I seeing that right? Yeah. Okay, let's clear the ink. Number 15. We have 1/2 times 12n minus 10 minus 2n. Okay, so I have 1/2 preceding the parentheses. I'm going to distribute the 1/2 over the parentheses. I'm going to write all the steps that go to it. So I have one here and here. So I get 1/2 times 12 becomes 12n over 2 minus 10 over 2 minus 2n. Remember, this one is just going to come straight down. It wasn't presenting anything over the parentheses. I can reduce 12n over 2 to what? 6n. Subtraction stays as is. 10 over 2 is 5. And then bring down the minus 2n. What are my like terms? 6n and the 2n. So 6n and subtracting 2n. I have 6n in my pocket. Something costs 2n. How much do I have left? 4n. Minus 5. There's that. Okay? Yes, ma'am.
I have a question about 30.
30, yeah. I'm going there. I can do that. Number 30. Oh, is that the with negative 80x plus 9 parentheses? Yes. Oh, perfect. I can do that. And then I'll get that last one, too. That's up there. Clear ink number 30. And then any other questions you might have. Negative 80x plus 9. And then 9x minus 4. Okay, so the negative 80x is going to come along for the ride for right now. So I'll just bring that straight down. I'm not going to distribute it over anything. I'm going to distribute that here and here. So I'm going to get plus 81x and then minus 36. Is that okay so far? You feel okay with that, everyone? So I am going through a store. Something costs 80x. I have 81x in my pocket. What do I have left? 1x, or I do have 1x indeed left, and then I have minus 36. So I could leave the answer like that. Sometimes we could write it like that. Both of those answers are 100% appropriate. Okay, don't let someone tell you, oh, you don't have to put a 1 in front of it. It's not needed. You'll be wrong. Heck no. Both of those are correct. Is that okay? And is that number 35 I see back there?
Yeah.
Okay. All right, number 35, we have 1/2, and then 6n minus 4 minus 2n. Does that seem okay so far? We are going to distribute the 1/2 to the 6n as well as the negative 4. The negative 2n is going to come along to the right. So I'm going to distribute here and here. So I'm going to get 6 over 2, or 6n over 2, minus 4 over 2, minus 2n. Reduce this. What does this reduce to? 3n. What does this reduce to? And then that comes along for the ride. My like terms are 3n and 2n, so I'm going to combine those together. So that's going to give me 1n minus 2, or you could write n minus 2. Again, both of those answers are correct. Is there any other questions that stemmed because of those? We have time to ask about it. Okay, some of you didn't feel so good about the distributive properties. Anything you want me to go back over, help you out, or did the questions you might have had get answered? Do you feel your answers got answered? You feel comfortable about it? Okay. Huh. All right. Perfect. So, Friday, we're going to have our first quiz. The quiz length is a front, back, and don't make that feel that it's an incredibly long quiz. It's just we give you some room. There was some of it will be matching up, like the answers will be written on the right side, and you have to kind of match what that was, and then others will be you'll have to work it out. Hey, what did I tell you all? If you needed more time, what do you have to do on a quiz or a test? If you need more time, just a smiley face by your name, right? And then that's on you to come in at, and make it up with me, to finish it up with me. I will not put it in the Math Science Resource Testing Center, okay? It's just sometimes, it's a really good thing, but sometimes it gets a little too crowded, and I have found that if you needed to come see me, you could finish it up pretty easily. So, good times to finish things up that might work for you. On Fridays, I don't have the medical class in the morning. So I'm usually here by about 6:15, 6:20 on Fridays, okay? And my office is kind of diagonal that way. By the guy's bathroom, go down the little hallway, you'll see my name on the plaque. I will usually be in there by about 6:15 on Friday mornings. If I'm not in there, that means I'm in here. If I'm not in both, that means I'm making copies. So just hang on and wait for me, okay? And if there's somebody in there, they'll usually say, oh, he'll be right back. He just left. Other than that, you would need to come over to my other office during one of your off times, which is the small building over here at the north side of the end zone, office 200. So you walk in the doors by the picnic tables, just pull on the door. Everyone thinks it's locked, so they ring the doorbell. No, just pull the door. It'll open. Go up the stairs. Office 200 is pretty much across from the stairs as you come up. Walk in, and there's 4 desks in there on one of the desks. Usually the one with the music on it. So just come in there, and then you can finish it up. Generally, what I can do is if you do put a smiley face on a test or quiz, I'm going to grade stuff pretty quickly. But if you had a smiley face, I'm not going to grade it yet. But I'm also not going to put a goose egg in on the computer. I'll give you a couple days so you can make the appropriate accommodations. My schedule, God bless you. My schedule today, I have a meeting at Swedish hospital at 9:45, so I'll be gone until about noon. And that is direct relationship to my medical class that I teach. That is why that meeting's taking place over there. So that's about it so far. Today is Wednesday, correct? So things are going well. Do you feel good about the pace? And is it an okay thing? Is it okay that I'm turning off my electronic devices as well as you? Does that seem to be a hindrance to you? Most of you are making it back every day, so I don't think it's really destroyed too much. But I just want to make sure. And I think some of you are realizing that I'm a pretty patient person. I'm not the guy going, well, one thing that really disturbed me, and this happened at a high school south of here. I remember I was sitting in the math office one morning, and I was helping two of my students. And a student came in to get help from the calculus teacher with a calculus problem. And the student got stumped on a basic arithmetic thing. Just kind of forgot. Like it slipped, just like life. Things are going to get forgotten. Doesn't mean like you won't ever be able to do it again. You just kind of had a little brain fart or something. And I just remember sitting there helping these kids, and there was an Algebra 1 kid that I was helping, and this teacher just looks right at this kid, and he's like, you should know how to do that. I'm not going to help you with that. And I thought, what a jerk. What a jerk. Why would you do that to a person? I mean, I know that myself as a dad, if I heard that like a teacher told my kid that and wouldn't help him, I would call teacher to teacher saying, hey, what's your problem? People forget things. Sometimes you need a little reminder. It's not like you have to go, okay, we have to go back to 3rd grade and reteach math. It's like, no, you just do it this way. Oh, yeah, that's right. And that could have been handled that way. All of a sudden, this student was shut down by this teacher, and I heard that student had eventually dropped that teacher's class. And that saddens me because that student could have had the opportunity to take that calculus, had all of the prerequisites to take that class, and that teacher chased that young lady away. That hurt my feelings. That hurt my feelings. So if something like that ever comes about that I did that, I want you flat out to say, look, quit being a jerk, pal, and show me. You have my permission to call me a jerk. Because I hope I never do that to you. And that frightens me that there are people who are teaching that do that. And I don't think that's cool. So I don't want to be that guy. And if I do become that guy, you let me know, dude, you need to retire. Because that way, because I don't need to be that kind of person. I really hope I don't. I love what I do. So I hope I never get to that point. And if I do, please tell me, you're being a jerk. Okay, can we do a couple notes? Let's see, we already did that. We have notes here. Yeah, buddy. Okay. All right. So this is getting into the part of algebra, and you might have been seeing this quite often. So you have the addition property of equality and the multiplication property of equality. And this just means I have one side equal to the other. But we don't know what the variable is equal to. And how this might have been presented to you earlier in math is you might have had a teacher saying, hey, what would I add to 10 to get to 20? Or what would I subtract from 15 to get to 3? Okay, so that's an algebra concept as an earlier phase in education. So all we're doing on this very first problem is we have some number x that we're going to add 5 to, and our result is going to be 10. Now, I get it. You can look at that right there and say, you know what? If I make x 5, 5 plus 5 is equal to 10. And that's absolutely right. But one thing that you might want to think about on these is this. Draw a vertical line straight down. That vertical line, I think it's good that that vertical line represents the equal sign. Okay? And I realize vertical line in math doesn't mean anything, but this is just makes it pretty easy. And what I'm going to say here, I think you might be able to follow the grammar of it. I want x to be all by itself. What I do to one side of this equation, I have to do to the other side. So if I added 300 to one side, I have to add 300 to the other side in order to make it equal still. So what I do to one side of my equal sign or one side of my bar, I have to do to the other side in order to keep it balanced. Okay, and I realized teeter-totters, which was a childhood thing that I had as a kid. It was basically a board that was sat, and you got on one side or the other, and you realized that either you were too heavy or your friend was too heavy because they would be down at the bottom and you'd be at the top. And then what you could do is you can move forward or backward on it, and you can get the balance out. It's called a fulcrum, and you're on a balanced scale. So that was a fun thing. Unfortunately, someone got sued because someone fell off one time and got hit in the jaw or something, and then they got rid of it because, that must happen everywhere. And that's kind of how life is these days. But what I do to one side, I have to do to the other to keep it equal. If you are on that teeter-totter and you are on one side, your friend was on the other, and it's sitting there right in the middle without you guys touching the ground or tipping back and forth, that just means you're equal weight. You weigh 140 pounds and your friend weighs 140, or you weigh 250 and your friend weighs 250, or whatever. So if I wanted to get x all by itself, I have to undo this. And it's a puzzle, but this is a real basic puzzle. This is not that puzzle where it's real complex, but a lot of the math that you deal with are puzzles, and it's just some sort of little step-by-step process will get you through. So what do you think I would have to do to each side to get x all by itself? Any ideas? Go ahead.
Minus 5.
Subtract 5, or minus 5 from both sides. I like it. So I subtract 5 from both sides. Those two cancel out. That leaves me x, and that's going to be equal to 5. So x is equal to 5 is our answer. Now, I get it. You were able to go through and comprehend that problem without even doing any math. I understand. But that right there is the math that would take place in order to get through there. Is that okay? May I move on? Okay. So, the opposite operation of addition is subtraction. The opposite of subtraction is addition. The opposite operation of division is multiplication. The opposite operation of multiplication is division. Is that okay? All right, so the next problem, if you were to do it how I suggested to do it, I said to do what first? Draw a vertical line right through the equal sign. And this is saying, hey, some number times x, or 3 times x, is equal to 18. So most of you could say real easily, well, it's going to be 6 because 3 times 6 is 18. You're absolutely right. But if we were to show this mathematically as a puzzle, what would be the algorithm to get x all by itself? What should I do to both sides? Divide by what? By 3. So I'll divide this by 3 and this side by 3. Those cancel out. That leaves me x is equal to 6, or 18 over 3. So x is equal to 6. Because 3 times 6 is indeed 18. That's pretty straightforward, I think. Okay, so the golden rule, what you do to one side of the equation, you must do to the other to keep it equal. Okay, if you were sitting on a teeter-totter, and you and your friend are equal and you're balanced, and then your other friend Jimmy comes and jumps on your side's not going to be equal to the other side, so you're going to go down. Or if your friend Jimmy jumped on the side with your other buddy, then your side is going to go up. It's not going to be balanced anymore because something took place to change it from being balanced. Can I erase that and move down? Okay. All right, let's scroll on down, see what we got. All right, here are a couple of examples. So problem number 1, could somebody just talk me through how to do it from the very first step that I would suggest? Want to? Good. Draw a line straight down. I like it. I like it. What would you do next? Subtract what? From both sides. So subtract 4 from both sides. I like it. All right, so those are going to cancel out. That's going to be x is equal to 12 minus 4 is going to be 8. So x equals 8 on this problem. Very well done. I like it. Well, somebody talk me through from start to end, in my terminology, how to do number 2. Go ahead.
Draw a line through the equal sign.
Draw that line straight down.
Divide both sides by 5.
Divide each side by 5. I like it. So those cancel. So x is equal to 5. I like it. Perfect. All right. A little tougher one. Someone want to take a little challenge? Fractions are the same thing as what? Math operation. I told you guys this the other day. It's the same thing as division. So what undoes division? Hey, what undoes division? What's the opposite operation of division? Multiplication. Okay. So somebody talk me through number 3. First step is draw that straight line, straight on down. Okay, I'm going to actually bring this one over here. I have 1/3 x equals 4. So I'm going to draw that straight line down. So we said fractions and division are the same thing. So we probably have to do some sort of multiplication. Okay? In order to undo this problem, I feel that if you were to multiply both sides by 3/1 and 3/1. Now, yes, 3/1 is the same thing as what number? 3. But in this case, we did this. These all cancel out. That leaves us 1x, or just x. And then I don't really need that 1, so 4 times 3 is equal to 12. So we find that this problem has an answer of 12. Is that okay so far? Okay, very last question as far as this group goes. What would my first step to this problem be? Talk me through what we would do. Number 4. Because number 3 I did right over here. I didn't have enough room. What should I do? First thing for number 4. Yeah. Draw a straight line right through the equal sign. What would you like to do next?
Add 12 on each side.
Yeah, it's subtracting 12 right now, but I'm going to add 12. That's the opposite operation. So I'm going to add 12 to both sides. So I'm going to get x is equal to, something costs $3 in the store. I have $12 in my pocket. Do I owe her or give money back? Give money, how much?
9.
So x is equal to 9. Love it. What do you think? Is that okay? I think that might have worked okay. Can I move on? And if so, can I erase what I have up there? So I have. Or I wonder if this works. Oh, that works. I don't even have to erase. Cool. Okay. I think this is the very last example. It says a physician's assistant. That's called a PA in the medical community. And just to give you a heads up, a physician assistant is not a doctor, but it's somebody who assists a doctor that has a higher order of operation than most nurses. Okay? That's what a physician assistant. If you had gone to the doctor lately, you might have seen a physician assistant if you were just going to see, have something minor done, like a physical or a checkup or something like that. And then what that physician does, or that physician assistant does, and this was incorrect. It should be a physician assistant, not hyphenated or apostrophe s. They would have report back to the doctor later in the day. Hey, I saw Billy today. Height, weight, blood pressure came in. Looked like strep. We took a culture. Culture came back positive. We saw that Billy was allergic to penicillin. I prescribed amoxicillin. Sounds good. Signs off. Good day. So a physician assistant measures a child and finds that his height is 48 inches. Okay, so the child is 48 inches tall, which is 4 feet tall. At his last visit to the doctor's office, the child was 43.5 inches tall. How much did the child grow? So let's set up an equation. We're going to say that x is how much the kid grew, or h, or q, or p, or z, or the Greek letter alpha. I don't care. We're just going to create a variable. So the child had been at a previous visit this tall. Okay? We want to find out how tall this child grows. So x added to the 43.5 what the last visit was, and then we're going to say is equal to 48 inches. So this child last year, 43.5 inches tall. This year came in 48 inches tall. Now, the math that takes place is pretty simple, but this would be the equation that would lead you to how to solve this child's height. So x, if I add some height to 43.5, that's going to allow me to get up to 48 inches. So now that I have my equation, what are we going to do? What was the first step to solving these equations? Draw the line. What should I do to both sides to get x all by itself? Subtract 43.5 from both sides. Okay, those cancel out easily. So I'm going to find that x is equal to, oh, that's going to be 48.0, right? Can you add a decimal with a 0 at the end? Is 48.0 the same thing as 48? And I'm going to subtract. Okay. Well, old school subtraction, if you don't have your calculator, make that a 7, make that a 10, because that value is smaller than that. So now 10 minus 5 is going to be 5. Decimals carry straight down. 7 minus 3 is 4, and 4 minus 4. So it looks like this child grew 4.5 inches, or 4.5 inches over the year. So did we answer everything? A physician assistant measures the child and finds that his height is 48 inches. At his last visit, to the doctor's office, the child was 43.5 inches tall. How much did the child grow? Does it seem appropriate that the child could have grown 4.5 inches between visits? I mean, that might happen to you. Some of you guys might have sprouted up quickly. Some of you might have grown slowly. And it's just who you are. There's nothing wrong with you. I mean, this is kind of silly about me. I was, from 5th grade to 7th grade, the tallest kid in the school. Okay? I grew to this height by 5th grade. People were like, dude, Stirrup's a giant. I'd be walking out, I'd be kidding the whole, hey, what's happening? I'm in 5th grade. I'm playing 2 divisions higher in football. Okay? I'm playing with the 7th grade team when I'm in 5th grade. Okay. Physically, I was about the same size as the guys I was playing against. Mentally, I was a 5th grader playing against 7th graders. Is there a difference between a 5th and a 7th grader? Heck yeah. I was down there going, man, I don't like this. I wanted to play with my buddies, but because I was like this gargantuan beast in 5th grade, they're like, no, you got to play on this team because you might hurt a kid in here. I'm like, so that was a little lull in my life. Darn Pop Warner football. Changing rules like that. It's not right. I blame that. That's why I'm not a professional football player now. I'm just kidding. No, I was not that good at football, though my sophomore year in high school I made varsity, which was pretty awesome. I made varsity, though, because all the guys that were on varsity, the coach had gotten fired. He was, like, bad. And they got this new guy in that was even worse. And so everyone who was playing varsity quit, and everyone who was playing JV quit. So like, hey, all you guys. I was like, sweet, dude, I'm playing varsity football as a sophomore. Defensive tackle. Oh, man. Our very first football game, we lost 77-7. And the 7 points was scored by a guy in a scoop 6 because they had like their 15th string, 3rd graders in. Because they were killing us. I mean, it's a running clock. It's a running clock after the half. The clock's running. That's when you score more than 42 points than the other team. And it becomes a running clock. And we're like, downside, there you go. Touchdown! Kickoff. I caught it. Kid run back, tackled. Dude, he's out of the game. Ambulance shows up. Oh, man, it was bad. Oh, we were horrible. It was fun, though, because we all got letters. Like, dude, I'm a varsity football player as a sophomore. That's pretty huge. But people would walk by. We'd go to our football games, and And there was more coaching staff at our games, our home games, than there was fans in the stand. 12 coaches standing there on the field, one guy up the thing going, all right, call this. I think the guy upstairs was actually, because we were so small and we sucked so bad, going, just tell them to do anything. Yeah, anything. Doesn't matter. They're going to lose the ball. Doesn't matter. So the coach would be going, punt. It's first down, coach. I don't care. Punt. Okay. The other team was like, why did he punt on first down? Fun stuff. All right, so enough about me, but I thought I'd give you a little silly. I think you guys should work on, it's page number 7, it's worksheet number 3, solving one-step equations. And I would really like it for you guys and girls to incorporate the practice of the vertical line, showing the operation of both sides, because it's showing the thought process. And I get it. It's kind of silly to do because you're like, dude, I can do it in my head. I get you. But it's good practice for when we get to a little bit more complex things, because not everything you'll see in here will be able to do in your head. Does that make a deal? Sound good? Yeah. Okay, so a couple of you